Hi, I'm David Strand. I'm here at the International Microwave Symposium in San Francisco, California. We're here at the convention center, the Moscone Convention Center, where I've got some amazing and awesome technology to show the world. So, I'm going inside. Let's go. I just got my badge, just ready to go inside, and we got to get down there fast because the giveaways that we got going on at the Santron booth and the Custom Mimic booth, they're hot. And oh, by the way, great beer festival going on. Here I go, real fast. Don't try this at home. Oh my God. I'm gonna randomly, Dave, I'm gonna randomly grab some of my best friends from the industry and see if I can get them to tell us what's going on with the show. I just found my friend John from Mercury Systems. How are you, John? I'm gonna jump over here. Hey, John, give me the skinny on what you think of the show so far.
Well, the show as always is pretty awesome. My name is John Bratton from Mercury Systems, and we're very pleased to be here. We've been sponsoring the show for a long time. So there has been a lot of awesome traffic. It's been high in volume. It's also been very good in quantity, and not just the customers and things stopping by, but some very good innovation things. We're seeing ideas not unlike the open RFM. It's sort of like a modular open systems approach to RF and microwave. So we're in a very mature industry, but the rate of innovation never seems to be higher than it has been this year.
Can you fill this part in?
Yeah.
Yeah, thanks. Appreciate it. We're here with the biggest guys in microwave, talking about the smallest things in microwave.
I just lost 30
Is that thing
pounds.
on?
That is not nice. I worked hard to lose that.
You did. You
I
trimmed
did.
up.
Jeez. We're a custom manufacturer of custom products. Our specialty is in photolithography of fine line features, so lines and spaces at the 10 micron or smaller size on a myriad of materials from a hard ceramic to a polyimide, Kapton, PZT, glass, sapphire, just to mention a few. The industry is constantly trying to drive the product smaller and smaller and smaller and get more performance out of the product, and we're able to support that by creating and pushing the technology envelope. We get smaller.
All I would say is that we're big enough, or small enough to matter, and big enough to and small enough to care.
You want to try that again?
I'll try it again.
I can do editing.
So we're here to share this excellent news about our brand new product that we're launching. Is a true surface mount circulator. The key features is an X-band set at 9 gigahertz, 10% bandwidth, emits less than half a dB of insertion loss, better than 20 dB return loss input and output, and better than 20 dB isolation. And it can also withstand up to 20 watts CW power, and it operates in the temperature range of minus 40 degrees C to plus 85 degrees C.
What is flying off the shelves right now, Pete?
Product-wise?
Yeah.
Definitely our high-frequency adapters and high-frequency cables. We do anything from DC to 67 gigahertz.
We came here to IMS 2016 to present our latest and greatest digital attenuator. This is the LDA 602EH, which is a 0.1 dB step attenuator, 120 dB range from 200 megahertz to 6 gigahertz. People doing Wi-Fi and cellular fading simulation, they needed a product that had fine resolution and a very large dynamic range.
I'm always trying to find a simple way to do something. My dad said, if you have a hard job, give it to a lazy person. So here I am. So I did not like all the O-rings that we were putting inside the connectors to make them pressurized. Too many piece parts, messed up the RF transitions, didn't work at low pressure. We needed a better solution. This connector on Manpack, our troops walking through the desert, sand and dust, walking through the forest, getting rained on, water, humidity is not going to penetrate this connector. That soldier is going to have free communications with the rest of his team because he doesn't have to worry about the humidity getting into his electronics.
Today, we're actually highlighting the latest release of our Picoscope 2000 series. This one here has 128 meg of memory built into it. On a real-time scope, memory is key. So you have your banner specs of bandwidth and sampling rate, but most people forget about memory when they're looking at and choosing for an oscilloscope. So on a real-time scope, if, for example, you have a 1 gigasample per second scope and you want to capture for 1 full second, that means that your scope would need to have 1 gig of memory built into it. So memory is key when you're looking at a scope.
What customers will find in our new Corvo library is that it's kind of in a multi-layer configuration now, where the top layer is your basic transistor with the gate, source, and drain pins. And then you could go down to the second layer, which has access to the sense pins, which is really important for certain types of designs, such as power amplifier design. It really enhances that type of design. And then there's the third layer, which gives you access to the core model and can be separated from the parasitics as well.
The demo behind me is based on a multi-chip module that's a SIGI and gas PA together with 2 BAW filters, so it's a wireless LAN and a cellular PA. And we're using shape modifiers to do yield analysis for process variations. So, it's a multi-stack laminate that we can vary the registration on and see how the performance shifts as a function of process variations. We're using electromagnetics to solve that, and we're using remote EM solve to split up that problem among many, many computers and then reestablishing it. So it's a huge problem that we're able to solve now. Very cool.
Hip, hip, hooray! Guys, here.
Cheers. Thanks, guys.
The next
Here's
10
to the next
years.
10 years. Cheers. Here we go.
Cheers, thank you.
We just developed a new set of mimic mixers that achieve state-of-the-art performance and form factors that are industry standard sizes. In the coming weeks and months, we're going to be turning many of these new chips into official products, and it's pretty much a new frontier for, I think, mimic mixers, really.
We're small enough to care, we're big enough to matter. I don't even know how I want to say it anymore. I'm really confused.
Well, I'd like to talk a little bit about our antenna technology, and in particular a polarizer product we've developed to address the E-band commercial communications allocation. So here we have a rather conventional Cassegrain reflector antenna. Here you have the machined reflector part here, the subreflector, and the feed horn. The polarizer would find itself behind the feed horn here. I have another example below here of a novel antenna we provided for someone. So we have a feed horn into a lens, but directly behind here is the polarizer. One of the other great things about this new polarizer product, of course, is that this design is completely scalable. So we designed it specifically for E-band, but we can design this for a large piece of bandwidth anywhere in the millimeter wave spectrum.
So really the market's getting hot with this laser system for patch antennas on LTCC material and on ceramics. Also for couplers and microwave filters. The laser is giving you very, very straight sidewalls with minimal, if any, effect to the substrate, and the performance of those filters and those couplers are actually matching simulation software more perfectly than a board that might have been done with an etching process where you could have an under etch and not quite be right on the frequency.
We are a small company mentality with a big business idea.
It's really awesome. These guys solve problems. It's perfect. Watch, I can do it.
All right, there we go. Very nice.
Copper Mounted Technologies was able to develop a 9 gig VNA with 160 dB dynamic range, which allowed us to introduce another multiplication stage into frequency extension and get it to 110 gig with the same parameters as traditional systems and the same performance at a much lower price point, because a 9 gig VNA is obviously a lot smaller. Thank you very much, and see you in Hawaii.
Yes.
Aloha.